Hello everyone, welcome back. My name is Animish Sharma. Let's start. So today we are making a 5-bit CLA adder in Verilog. I'm going to use iCrest Verilog for this. Just download the latest stable version from here and install it using this setup. Go here, go to next, accept, next, 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 and I already have that, so I don't need it. So let's start from building our Verilog. So we are going to make a Verilog also GTK-Wave stable. So okay, start. We are gonna need the stop. So let's start. So first we are going to define our time scale. So time scale would be 1 nanosecond divided by 1 picosecond because we need our clock to be better. So let me just turn off this. Yeah, thanks. So let's make our D flip flop first. So I hope you all know what a 5-bit CLA adder is. So we are gonna make this width equals to 5, and our input is going to be a clock. It is going to be 0D. D always takes a D, and our output is going to be, sorry, width Q. So we all know what a D flip flop does is. So if you don't know what D flip flop does, let's go to Google. Okay, till it's processing. So let's just put an output whose edge clock Q is always more than equals to D. So what does this line mean? So let's see. This module actually ends here. This has to be moved up here, and this would be end module. Yeah. So what does this mean? So see this. So the characteristic equation of is Qn plus 1 is D of n. So if Q is 0, Dn is 0, then it would be 0. If Q is 0, Dn is 1, then it would be 1. If Q is 1, Dn is 0 is 0. So the next state of Q would be what is the current state of Dn, and we are using posage of clock, then setting Q is equals to D. So after this, so we all know that there is P and G in CLA adders. I hope you remember what those are. If you don't, so basically P is equals to A B, A XOR B, and G is equals to A or B, A and B, sorry. If you remember that, then we can write our module of P and G. So module PG, let's name it generation. So what it's gonna have, it's gonna have an input of 4 to 0 because we're gonna have 5 bits, and input of 4 to 0 of B, and output of 0 of P and G. Okay, now we are just gonna assign all these values, like P is equals to A XOR B, and sorry, assign G is equals to A and B. So if you don't understand the theory in all this, I'll explain the theory in a bit. So let's now work on our main CLA unit, and then the carry unit. So we're just gonna see module CLA unit, gonna have an input Cin, input of 0 of P, V. We need anything else? No, I don't think so. We need an output of C. Okay, now, okay, I think we can start by assigning those. So and module, so assign C0 is equals to G0. Okay, I guess I have to make this in bracket or P0 and Cn. For this is going to be P1, oh sorry, P1, G1, sorry, C1, P1 and G0 and P1 and P0 and Cn. So basically this is the the derived big form of C1 and C0. So we all know that Ci plus 1 can be written as Gi and Pi and of Cn. So Gi or Pi and of Ci, whatever that. So this is Ci plus 1. So if I wrote Ci C1, so it would be G1 and of P1 and C0. So now C0 is this term. So if we put it in here, this would be the long form of that. So like that, we are going to have four different like C2 same. So this would be G2, P2, G1, and this would be P2, P1, G0, and P2, P1, and P0 and Cn. Like this again, we have to expand it all the way. So this time, this would be C3 is equals to G3, P3, G2, P3, sorry, P2, G1, P3, P2, P1, this would be G0, and a very big and, this would be P3 and P2 and P1 and P0 and Cn. So for the last, we're just gonna copy it. 4 G4 P4 G3, I hope. Or we can actually just do a simple, we don't have to expand it all the way actually, we can just do assign C4 is equals to G4 and of P4 and C3. That's another way of doing it. So yeah, this is our CLA unit. Let's make our sum generation unit. So this would be module sum gen. So it will take input P C, that would be previous, and an output that would be sum. Yeah, let's end module here and assign things. So we know that sum is C previous XOR of P. So after this, now it's time for our main CLA 5-bit unit. That would be CLA 5-bit. So we are gonna have input A, B, and input Cn, and output sum and output Cout. So I hope you understand where are we going with this. So how do we do this? So let's just first end module here. So we were gonna have a wires P, G, and C. Okay. So PG generation, we're gonna give A, B, P, and G. I hope that was the correct A, B, P, and G. Yeah. Output A, B, P, and G. Yeah. So once we have our PG generation here, we can go ahead and use that in our CLA unit. So we also have to name this PG. So we are going to have our CLA unit. That would be, let's see CU, that was CN that takes, I'm pretty sure. CLA unit, yeah, CN PGC. That is PG and C. And then we are going to have a sum unit SG. Sum unit takes P C, but the C has to be previous, so it's going to be previous sums including this, and Cn, wait, this has to be outside, yeah, Cn. So this is our module. Now combining CLA 5-bit with our D flip-flop to feed the bits to it, we are gonna write our main module, that is top. So it's gonna have an input clock, input 4 to 0 AN, say BN, output sum out, and output C out. So in module, so wire, so let's name it AR, PR, and SW for now, and a single wire that is going to be CW. So D flip-flop, snag 5, so we are going to name this DA. It's going to take a clock, an AN, and AR. Similarly, same 5 clock, this is going to take BN and BR. So two D flip-flops we have, and then our CLA 5-bit, I'll name it CLA. Okay, it's same name. Okay, CLA, I'll take AR, BR, it's gonna take is the B0, SW, and CW. It's gonna return sum and that, and then we can have a D flip-flop of 5 bits, name it DS, which will take clock, SW, and sum out, and single bit D flip-flop, and C out. Yeah, I think that is it. Yeah. Now we have to write a test bench for this to make it work. So let's say tb top.v, and so now with writing a test bench, same time scale, we're gonna copy. Okay. Yeah. So module tb top. So we're not gonna take anything, and we're just gonna end the module. Okay. So gonna clock and A, so that's gonna be A, same for B, and a wire we are gonna take for sum, and for a wire for C out. Yeah. So let's pass this to our top and name it dot clock. That's gonna be clock in, that is going to be A, B in, that is going to be B, sum out. Did we write sum out here? Top sum out, yeah. And C out, that we wrote C out, yeah. So initial begin, okay, it's already written. So initially clock would be 0. Let's say A is 0 and B is also 0, and we are just going to dump a file. We're going to name this dump.vcd This is for GTK-Wave, and we are going to dump some variables. So for that we have to write dump vars vrs. So we're going to dump 0 comma tb top. If you don't know why it is done, I'll explain inside the video. So now let's try this. So let's say A is 10, B is 2, and do it for 5 times. Yeah, let's say A is 31 and B is 31. Say A is 0, B is 0, A is 11, B is 21, A is 1, B is 1. And we have to tell that it is finished. So finish, and always we have to switch the clock. So after 5, clock is off, clock opposite of clock. Okay, so let's run this. To run this, it's really easy. You just have to write I verilog dash o sim top.v and tb, oh shit, tb top.v. Syntax error, third line. Okay, I think we made some mistake here. So parameter, I see, should not be here. Okay, some problems here. Okay, yeah, 22nd line. Yes, we made a lot of problems, I guess. Yeah, ds has already been declared above. Yeah, let's just name it dc. Why does it matter? Okay, so yes, our simtop has been there, so we just say vv simtop, and we can say GTK-Wave dump.vcd, and let's check our result. So A, B, clock, cout, and sum. Okay, so let's just zoom this a little bit. So as you can see here, it is 0, and cout is also 0. Okay, nice. Sum is 0 on the other edge. Okay, good enough. When it is 1 after one edge, it is 2. Yes, correct. Now this is in hexadecimal, so you have to understand what is going on here. Okay, I think cout is not being properly done here. Or wait, sum is correctly being processed, but is cout being correctly processed? I don't think so. Is equals to z. Okay. 0a and 02, 0c. Okay, correct. 1f, correct. Yeah, there is some problem in cout. Let's see what's the problem here. I guess it's in this line. So let's check it once. Cn G1 P1 G0 P0, same, yeah, correct. G2 P2 P2 G1 P2 P1 G0 P2 P1 P0, seen, correct. G3 P3 G2 P3 P2 G1 P3 P2 P1 G0 P3 P2 P1 P0, seen, correct. It is correct only, but are we sure we are not making any problems? Okay, let's see here. We did cout. Okay, good. Cout is cout. And we are taking cout from, okay, I think I know what the problem is. So output C out. Yeah, that is the problem here. Okay, so here forward one line to assign C out is equals to C4. That's the whole thing. So we have to do this again. So I Verilog PV top. Now it should be correct. A B C C out sum. Yeah, let's smoothen this. And now okay, where's C out? Yeah, correct only. So 1F, yeah, after 1 edge it is showing 1E, correct. Yeah, I think it is showing correctly. Thank you for this part. Next part we are going to do the ngSpice part of it, and maybe after that we will do the magic part of it. If you want the theory of this CLA adders, we can also do that. Thank you very much. This is Animish Sharma signing off.